Hello again. We are covering 11.2, another conic section called ellipses. Okay, so this is when you slice a cone kind of at an angle, um, and instead of getting a circle, you end up with this oval, which we call the ellipse. Okay, so 11.2, ellipses. Okay, so let's start off with a definition of what an ellipse is, also um, a geometric definition. All right, so here it is the set of all points in the plane the sum of whose distances from two fixed points F1 and F2, and these are the two focus points called foci for plural. Okay, so whose distances from two fixed points is always constant. It's the same, no matter which point you choose on the ellipse. When you look at the distance from that point on the ellipse to two focus points, that distance, when you add them up, those two distances are always going to be the same. Okay, so here's a visual. Okay, so it's sort of this oval shape, and you have these two fixed points, and you have sort of this oval. Okay, and so what it's saying is that all the points on the ellipse. Okay, so when you take this distance, call that D1, and you take the distance to the other one, clearly longer. Okay, so I'll call this D2. Okay, then what happens is when you add those two distances together, you get some constant, right? I'll call it capital C. Well, they're saying that if you take another point on the ellipse, so let me do this one, and you take the distance from that point to the focus, and you take the distance to the other focus, call it C2, then when you add those two distances up, you also get a constant. What they're saying here is that when you add those two up, you're going to get the exact same constant as the other two. Okay, so that's the definition of a geometric definition of the ellipse. Okay, all right, so let's take a look at the equations. Okay, so the if you take a look in your book, it gives you two equations of the ellipse. I work with just one, and I generalize everything else. Okay, so there's less to memorize. Okay, so if we take a look here, it would have this form: x squared over a squared plus y squared over b squared equals 1. Okay, so when it's written like this, so it should always be set equal to 1. Okay, and maybe the denominators are perfect squares, and maybe they're not. Maybe it's like 16 and 25, or maybe it's 7 and 11. Okay, so they don't have to be perfect squares. Okay, but they do play a role in in graphing the ellipse. Okay, so when it's written in this form, we know a lot of things. We know that the center is going to be at 0, 0. We know the horizontal axis length. Okay, so horizontal is like the x direction, right? So to find the horizontal axis length, we're going to take a look at the denominator underneath the x, which makes sense, right? Okay, so if that's a squared, then the axis length is going to be whatever the a is times 2. Okay, and we know the vertical axis length. Okay, so vertical, that's the y direction. So we would look at the denominator of the y squared, okay? And it would be 2 times b, okay? And one thing over here. So we have these two axes, the horizontal axis and the vertical axis. So the longer of the two, so the one with the larger denominator. Okay, so the longer axis is the major axis. And the shorter one is the minor axis. Okay. All right. Okay, so the two focus points, okay, the foci, are going to be c units away. From the center. Okay. From the center. And which direction? You go the direction of the major axis. Okay, from the center along the major axis. So you'll need to know which one is the major axis. And again, it's the larger of the two denominators. If x squared has a longer denominator, then you'll go sideways. If y squared has the bigger denominator, then you'll go up and down. Okay. So the question is, how do you find that c value? Okay, so turns out c squared is going to be equal to the absolute value of a squared minus b squared. Okay, so by using the absolute value here, by using the absolute value here, I eliminate having to have two formulas. Okay. All right, so let's take a look. All right, an ellipse has the equation x squared over 9 plus y squared over 4 equals 1. So, I mean, just by looking at this, we see that x squared has a bigger denominator, so we know that it is going to be elongated horizontally, okay? Find the foci, which will be along the x-axis, okay? Find the foci, the vertices. The vertices here are just the endpoints of the major axis, okay? Okay, and the lengths of the major and minor axes. And then sketch the graph. Okay, so let's take a look. All right, so just from looking at the equation, I know that the center is at 0, 0. Okay, and I know my horizontal length is going to be, so square root of 9 is 3, so 2 times 3. And my vertical length will be, okay, so vertical, that's under the y, so square root of 4 is 2, so it's going to be 2 times 2. Okay. And then my C value, I'll need to find that. Okay. So you just basically take the larger denominator minus the smaller one. If you do that, you don't have to worry about the absolute value. Okay. So 9 minus 4. Okay. So C squared equals to absolute value of 5, or C squared equals to 5. So C equals to square root of 5. Okay. So that's pretty much everything that we need. So when I graph this, we know we're going to have the center at 0, 0. Okay. And my horizontal length is 6. So that's going to be 3 on each side. 1, 2, 3. 1, 2, 3. And my vertical length is 4. So that's 2 above and 2 below. Okay. So here is my ellipse. Okay. And my foci, okay, so they're going to be along the major axis this far away. Okay, so we're going to have your foci. You're going to have one at negative square root 5, 0, and you're going to have one at positive square root 5, 0, which is 2 point something. So you'll have one right in here somewhere, and 1, 2, and one in here somewhere. Okay. I promise I won't break out my tape measure to make sure you're exact. Okay, so I think we got everything. Find the foci. We did. Vertices. Okay, my vertices. So they're the endpoints of your major axis. That's these guys. This one and this one. Okay, so we have one at 3, 0 and at negative 3, 0. Okay. So we found the foci, the vertices, the lengths of the major and minor axes. That's this and this. And sketch the graph, which we did. Okay, so we got all of those in there. Okay. All right, let's take a look at another one. All right, let's find the foci of the ellipse. 16 x squared plus 9 y squared equals 144, and sketch the graph. Okay. All right, so let me bring down that equation. So this equation here is not written in our standard form because our standard form has these ellipses set equal to 1. Okay, so if I want this to be set equal to 1, then I need to divide everything by 144. Okay, and I'll get 1 here. Okay. And here, these guys will cancel out. 16 will cancel out with 144 because 16 actually goes into 144 9 times. So these guys cancel out, and I get x squared over 9. And 9 goes into 144 16 times. Okay, so now I have it in standard form. Okay, so now what am I supposed to do? Find the foci of the ellipse and sketch it. All right, so we know that the center is at 0, 0. We know that the horizontal length is square root of 9 times 2, right? So that's 2 times 3. And my vertical length is square root of 16, which is 4 times 2. Okay. And then my c squared is going to be the larger denominator minus the smaller one. So 16 minus 9. So c squared equals to 7. So c equals square root 7. Okay. All right. So let's go ahead and sketch this. All right. So center at 0, 0. Okay. My horizontal length sideways is 6. So 3 on each side. 1, 2, 3. 1, 2, 3. My vertical is 8. So 4 on each side. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So it's just a little bit larger vertically. Okay. Okay, so that means that I have to go square root 7, which is, again, 2 point something along the major, and vertical is the longer, so it's going to go 1, 2 point something right in there somewhere, and 1, 2 point something right in there. Okay, so my foci are going to be at 0 square root 7 and 0 negative square root 7. Okay, was I supposed to find anything else? No, find the foci and sketch it. Okay, found the foci and we sketched it. Okay, let's take a look at another one. Okay, the vertices of an ellipse are at plus minus 4, 0, and the foci are at plus minus 2, 0. Find its equation and sketch. Again, whenever they're asking you to find its equation, I always start off with the sketch. Okay, and sketch the graph. Okay, because sketching the graph gives me a lot of information. Okay, like the ellipse, the vertices are at plus minus 4, 0. So 1, 2, 3, 4, 0, and 1, 2, 3, 4, negative 4, 0. Okay, those are the vertices, right? And then the foci are at 2, 0, and negative 2, 0. Okay, since those are the vertices, it means it's longer horizontally than it is vertically. Okay, so it's kind of something that looks like this. Okay, so that means we have to find these guys, the denominators. Well, we know the length, the horizontal length. Okay, so 1, 2, 3, 4. So this has to be 16, right? Okay, because it's here. Let me get a different color. This is 4. So this here, I got it from doing 4 squared. Okay. The focus, the distance for the focus, this is 2. Okay. That's my C value. Okay. So I don't know this Y value. This one I'm trying to find. Okay. I don't know anything about it, but I do know A squared and I do know C squared. And so I can use that almost Pythagorean looking formula. Okay, so here, let me get my black ink. Okay, so I do know that C equals 2 and that A equals 4, right? And so I can use that formula. So C squared equals the longer one. The longer one is going to be 4 squared. Oops. Let me write the formula first. The longer one minus the shorter one. The one that's missing is B, and it's the shorter of the two. All right, so I'm going to plug in for C, and I'm going to plug in for A. 2 squared equals 4 squared minus B squared. 4 equals 16 minus B squared. Negative 12 equals, oops, negative 12 equals negative B squared. And I really only need B squared, so B squared equals 12. So then my equation is x squared over 16 plus y squared over b squared, which is 12, equals 1. Okay, so that's how you find, that's how you write the equation. You have to really sketch the information that you have and really try to extract what you do know. You'll know one of these for sure. Okay, so you'll know one of those, and you'll have to use this formula to find the other one. Okay, so let's take a look at another one. We'll wrap it up. Okay, find an equation. There's that find the equation again. So sketch everything first. For the ellipse. For the ellipse with endpoints of the minor axis. So the minor axis at 0 plus minus 3. And the distance between the foci, so the distance between the two focus points, is 8. Okay? So again, whenever they're asking you to write the equation, you want to sketch all the information so that you can try to extract as much of the equation as possible. Okay, so endpoints of minor axis at 0, 3 and 0, negative 3. So right there and right there. Okay, so that's the minor axis. Okay, and so we know that it's going to be longer horizontally. Okay, because this is the minor axis, which means the major axis is horizontal. Okay, so the focus points are always along the major axis. And it says here that your distance between your two focus points is 8, which means I have 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so you have a focus point here, and you have a focus point here. Okay, and you're something like this. Okay, So we know that it's x squared over something plus y squared over something equals 1. Okay, so when we take a look at this, we know the vertical axis. Okay, so we know that. Okay, so we know that this distance is 3. So over here, under the y value, the y squared is going to be 3 squared. Okay, this one is missing. This focal distance, okay, is 4. So I know my c value. Okay, so let's take a look. I know c equals 4. I know b equals 3. Okay, and I know a is the larger of the two. Okay, so I'm going to use c squared equals the larger one, which is going to be a squared minus b squared. Okay, so let's plug in and solve for that a squared. So 4 squared equals a squared minus 3 squared. Okay, so here I get 16 equals a squared minus 9. Add 9 to both sides, and we get 25 equals a squared. So a squared is 25. So I get x squared over 25 plus y squared over 9, right? Yeah, equals 1. Okay, so that's how you would come up with the equation. Again, sketch everything first. Do this first and try to extract as much information from it. You should be able to get one of the denominators, okay? And you should be able to get the c value, okay? If you can get that, then all you need is this formula right here to find the missing denominator, okay? All right, if you have any questions, make sure you email me or send me a text message.